My name is Jasper Jacobson, and I'll be presenting on the states of matter. So first is gases. Kinetic molecular theory describes the behavior of gases in terms of particles in motion. All collisions with gases are elastic collisions in which no kinetic energy is lost. There are no big significant attractive or repulsive forces among them. You can find the kinetic energy of a particle with kinetic energy is equal to 1/2 times mass times volume squared. Pressure is the force per unit area. Gases create pressure by colliding with the walls of their containers. Pressure can be influenced by the volume or the amount of gas. The low pressure cylinder is low pressure because of the large amount of volume and the small amount of molecules. And the high pressure cylinders in the picture are high pressure either because of the low volume or the high amount of particles. These are some of the measurements for pressure and how many ATMs they are equal to. ATMs are equal to the amount of pressure the atmosphere exerts, and Dalton's law of partial pressure is an equation for finding the total amount of pressure, which is at the bottom right there. Diffusion is a material moving through another, like perfume particles spreading across the room. Partial particles diffuse from a high concentration area to a low concentration area, and effusion is where a gas escapes from a small opening. You can find the rate of effusion with the equation in the picture. Intermolecular forces are identical particles, or what hold identical particles together. The first type of intermolecular force are called dispersion forces. Dispersion forces are weak forces caused by temporary shifts in electron density in electron clouds. If more electrons are on one side than the other on a molecule, it creates a temporary dipole and causes other molecules to form dipoles, in which causes them to stick together. Dipole-dipole forces are forces that happen between polar molecules with permanent dipoles, and hydrogen bonds are a dipole-dipole attraction containing hydrogen in a highly electronegative atom such as oxygen that makes a dipole. Liquids are much more dense than gases. Liquids can be pressed, but not as much as gases because they are already tightly packed. Viscosity is a measure of resistance to flow. For example, syrup is more viscous than water. Viscosity decreases with temperature. Surface tension is the energy required to increase the surface area of a liquid by a given amount. Surface tension is a measure of the inward pull by particles to the middle. Things that lower surface tension are called surfactants. Solids are more closely packed than liquids, except for ice, which is less dense than its liquid form. Crystalline solids are solids that are arranged in a predictable way. A molecular solid are solids that are held together by intermolecular forces. Ionic solids are held together by ionic bonds. Metallic solids are metal ions surrounded by a sea of electrons, and amorphous solids have no regular pattern. Phase changes that require energy are melting, vaporization, and evaporation, and sublimation. Melting happens when solids turn into liquids. Vaporization is a liquid turning into a gas. Evaporation is when vaporization happens only at the surface of a liquid, and sublimation is going from a solid to a gas. Phase changes that release energy are called condensation, deposition, and freezing. Condensation is a gas turning into a liquid. Deposition is a gas turning into a solid. Freezing is a liquid turning into a solid. And lastly, a phase diagram is a diagram of pressure versus temperature that shows what phase a substance is under different conditions. So the triple point is where solids, liquids, and gases exist at the same time, and that's my states of matter presentation.